Here we have a right angle triangle. Pythagoras' theorem says that if we square the longest side of a right angle triangle, it will equal the sum of the squares of the two short sides. So in other words, if we multiply 3.74 by itself, the value we will get is equal to the sum of the squares of the two short sides. In this case, 2.64 squared plus 2.65 squared. Now, squaring a number is the same thing as getting the area of a square whose sides are equal to that number. So for example, squaring 3.74 is the same thing as getting the area of a square which is side 3.74. So that's why we call multiplying a number by itself squaring. So the area of this red square here is equal to the area of these two green squares. So we could put these two green squares together and fit them into this area here. So this is only true for right angle triangles. The three sides are connected in this way. The three sides are connected by this relation. The square of the hypotenuse, as the long side is often called, equals the sum of the squares of the two short sides of any right angle triangle. Since the three sides of a right angle triangle are connected by this simple formula, we can find a missing side of a right angle triangle. If we know two sides of a right angle triangle, we can easily find the missing side. So in this right angle triangle, the longest side is the missing side. This side is also called the hypotenuse, so I'm calling it H in this example. The two short sides are of lengths 4 and 3. So the square of the hypotenuse, or H squared, equals the sum of the squares of the two short sides. So we square 3 and square 4, sum them to get 25. To find H, we get the square root of 25, which is 5. So this is the most famous right angle triangle. Right angle triangle of sides 3, 4 and 5. If we put three sides of length 3, 4 and 5 together, we always get a right angle triangle. Here is another example of a right angle triangle whose sides have integer lengths. The hypotenuse here is 13. So by Pythagoras, 13 squared equals 12 squared plus m squared. If we rearrange this, we get m equals the square root of 13 squared minus 12 squared. This is the square root of 169 minus 144, or the square root of 25, which is 5. So this side here is 5.